Okay, let's first talk about the IV characteristic of LDR. And LDR's resistance does change with the level of illumination. The brighter is the environment, the lower the resistance. But at one particular temperature, the resistance is one particular value. So it's an ohmic device, and its IV characteristic graph should be a straight line passing through the origin. If you shine more light onto the LDR, then its resistance will drop to a new value, but it will still be a straight line graph that passes through the origin. Likewise for the thermistor. At one particular temperature, the resistance of the thermistor is fixed. It's the ohmic device, its IV characteristic graph passes through the origin. If you hits up the thermistor, the resistance drops, then it becomes another straight line, but it also passes through the origin. Alright, so both the LDR and the thermistor cannot be this device that's shown here, because clearly this one, if it continues as a straight line, it doesn't pass through the origin. Okay, what about a piece of wire? Isn't a metallic resistor an ohmic device? Yes, actually it is, but the problem is as we increase the potential difference across a piece of wire, the current will increase, and therefore the power dissipation in the wire will also increase. In many practical situations, when we increase the power dissipation in the wire, it actually heats up very significantly. Its temperature jumps by a lot. From room temperature, it can reach a few hundred degrees Celsius. So with such a big increase in temperature, the resistance of a wire actually increases. And so when it's hot enough, you'll see that the resistance starts to increase. So it's no longer ohmic once it's hot enough. Alright? But anyway, you can see that this doesn't fit this shape here. So this cannot be the IV characteristic graph of a piece of wire, like a filament. So the one that fits would be this one, which is the IV characteristic graph of a non-ideal diode. So it shows a very large resistance when it hasn't reached the forward biasing voltage yet, but once it's in forward bias, the resistance will start to drop significantly.